Welcome to our podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore can Google's quantum computers replace PCs? Researchers at Google say they have achieved quantum supremacy, in which a computer harnessing the properties of subatomic particles did a far better job of solving a problem than the world's most powerful supercomputer. Quantum supremacy is a holy grail for researchers in the field. It's when the superior potential of quantum computing is finally achieved in practice, effectively superseding existing forms of computing. Conventional computers use bits, or ones and zeros, as the basis of their calculations. In simple terms, these represent yes and no or on and off. In combination, bits can be used to handle logical tasks. Quantum computing makes use of a property of subatomic particles in which they can simultaneously exist in different states. A quantum bit, or qubit, can thus be both 1 and 0 at the same time. In the jargon, this is called superposition. Another property of subatomic particles is for them to become entangled, meaning that they can influence each other's behavior in an observable way. Combining entanglement with superposition leads to exponential increases in computing power with each additional qubit. The Sycamore processor designed by Google, a unit of Silicon Valley technology giant Alphabet, had 54 qubits arranged in a two-dimensional grid. In the experiment, only 53 could be made to work, still enough to produce a successful result. Physicists have been talking about quantum computing for over 30 years, but the challenges of making it work are daunting. The qubits need to be cooled to just above absolute zero to reduce noise or vibration that introduces errors into the calculations made by a quantum computer. Google's researchers, in solving the problem with a high degree of fidelity or accuracy, can reasonably claim to have achieved a significant milestone, say physicists. Critics, including rival IBM, say Google is hyping its achievement and creating the misleading impression that quantum computers have effectively rendered all conventional computers obsolete. By adding disk storage, the Summit supercomputer, which is made by IBM, could have solved Google's random number problem in at most 2.5 days. With greater accuracy, they say. Skeptics also argue that Google has only solved a very narrow task, and that quantum computing is still a long way away from practical use. In the real world, quantum computers are likely to work in harness with classical computers, making use of their respective strengths. Researchers from the Google AI research team see potential uses for quantum computing in fields such as machine learning, materials science, and chemistry. They admit, though, that still greater accuracy will be needed to bring those use cases into the real world. Cryptographers are, meanwhile, already preparing for the day when quantum computers might be used to crack the codes used, for example, to secure online access to bank accounts. So, even before quantum computing becomes widely used, post-quantum cryptography is already here. Google, with its quantum supremacy headline, is staking a claim to leadership in the field, but IBM is a close rival. Applied research is growing and startups are springing up too. It's possible to book time on a quantum computer hooked up to a cloud server to do research work. China, which has invested heavily in fields such as artificial intelligence, is also backing quantum computing, making it another front in its evolving trade and technology Cold War with the United States. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.